Hey guys, we're going to finish kind of talking through this chapter today. I'm just going to hit a few key ideas off of the last video one more time, and then we just have two little sections to kind of talk through, so it should be not too bad. So when we're talking about electric shock, remember it's damaging if there is current passing through a body. And to have current, you have to have a difference in potential from one location to another, or you have to have a voltage. Remember, voltage is a difference in potential. You have to have a voltage difference there. So a bird sitting on a wire, the wire's got electricity constantly going back and forth. It's AC, but it's the same amount of energy here as there is here. So the bird doesn't get shocked. But if you touch a power line, you're touching the ground. And there's a difference in potential energy between the wire and the ground, and so quickly a current would pass through you and cause a great amount of damage because you're grounded. Okay, and then the other thing we have are two kinds of electricity. So direct current DC is always going in one direction. It's going, electrons repel, they just kind of go in a simple circle. Usually these are powered by a battery. Whereas AC is alternating, meaning it's just constantly going back and forth, 60 times per second. Remember, hertz means per second. And I'm going to cross out 0.8 and 0.9. So go ahead and go now to the back page. Okay, so we talk about electricity as electrons moving. But you have to remember, there's electrons around every atom, right? So every atom has its very own electrons. So the source of the electrons is from the material itself. Okay, so if I, ignore that for right now, draw here's my plug-in. See how good I can draw a plug-in. There's a plug-in, and here's a lamp. And one of those pull down chains, okay? So I plug in my lamp. Here's the cord. It's plugged in. Okay. So remember, plug-ins are AC, alternating current. Okay. So all along this cord there are electrons. All throughout all the wiring in here. And then I get to the light bulb. There's electrons all up in the light bulb. Okay, and then they go back. Okay, so the electrons of the current are alternating. They're going back and forth in place. Okay, so this electron might be going back and forth in this tiny little space of area. Because remember, it's going back and forth 60 times per second, the direction. So it's going back and forth, back and forth, back and forth 60 times every second. So one electron is not going from the plug-in through this circuit, through the light bulb, and back, right? One electron is just buzzing back and forth, back and forth, back and forth, back and forth, back and forth. And that's the alternating current idea, is that the electrons don't have to move very far as long as they are moving, right? So they are moving just back and forth within a very small amount of space. So it's the energy that's flowing out of the outlet to cause the electrons within the material to go back and forth. Okay, so it's the vibrating motion that are already present that kind of make things happen. So that's kind of the big idea there. Okay, and then we have this idea of power, which we talked about power earlier this year, and we talked about power being work over time, or how fast work gets done. And it is the same idea here, we're just thinking about it kind of a different way. Okay, so remember, work is moving something, right? So work with moving something is always moving something. In this case, it's charge, right? So it's basically how much charge is being moved per time, but what causes the current to go faster would be a larger voltage. So even though we're using current and voltage and we're going to actually multiply them. That's because if we have a larger voltage, it takes less time. Okay, so basically I have kind of this idea in the electrical side of it is this is times voltage, but remember, more voltage would make it less time. So it's kind of working the same way here. So it's the rate at which electrical energy is converted into another form, such as mechanical energy, heat, or light. So here's our general equation. Power equals current times voltage, and then here's our appropriate units, right? Power is measured in watts equals current, which is measured in amps or amperes, times voltage, which is measured in volts. And then we have this really weird idea, which is the kilowatt hour. And if you ever go shopping for appliances, sounds really fun, you'll see a lot of appliances labeled with like their kilowatt hour rating. Okay, and it's not, so watts is a unit of power, and hours is a unit of time. So how do we go from a unit of power and a unit of time to an amount of energy? Well, again, let's think about this. So power is generally work divided by time. So if I'm looking for energy, remember work is equivalent to energy. They're both measured in joules. So if I rearrange this equation to work equals, it'll be power times time. So then we'd have watts, and we can put time into hours if we want. So it's a really kind of a weird unit. But basically it's just saying this is kind of how much energy this is going to consume. So the lower kilowatt hour appliance you have, the better for your electric bill. And so it's kilowatt hour, not a kilowatt second. And it's a kilowatt, not a watt. So it'd be in 1 hour, how many kilowatts is it going to use? Okay, so it's the amount of energy consumed in 1 hour. So it's kind of a weird one. Okay, with that should be the end of the chapter. I did kind of, I picked out questions I thought that you could probably find the answers to pretty easily, but it's still kind of good to go over these concepts so that when we do the application, the math stuff, which is going to be pretty much all that's left, you haven't, ignored them for a week and a half. So on this page 291, okay, it looks like this at the top, 291, down at the bottom, right, 291. Go ahead and cross out 21 and 22, and then go ahead and you can cross out 27, and then the entire back page, we're going to ax it, okay? So then you should have one more practice exercises page, and you can cross out the top 41, 42, 43, and then I want you to do the rest of it minus number 47. And again, I think that I made it so you should pretty easily able to find the answers if you kind of scroll through the summary thing. And again, they're organized by section, just like these are organized by section. So you should have some questions on 291 and some questions on 293 to do. Let me know if you have any questions. And again, please take a picture and submit your answers on Google Classroom, not in an email. They just are less likely to get lost. All right, tomorrow we'll do some more math, so look forward to that. Talk to you later. Bye.